Alright, so very, very important day, okay? I've told you that this unit is so important as far as a whole year of understanding. I want to make something real clear, real quick, making sure everyone is good to go. The 12 points that were given on last test will only happen one time of year, okay? So the biggest reason of that 12 points, just so that you understand, is so that people don't lose drive, momentum, and work ethic, okay? Keep pushing. I know you're tired. I know you want to go home and eat some turkey and sleep, and I know that, and so do I. But at the same time, please keep pushing. I can't stress how important this unit is in overall understanding for your AP exam at the end of the year. Okay, with that being said, the bonus points that we do here on out, there won't be a blanket, everyone's just going to get these points, okay? The accountability level changes the second semester. There are no more attempt points, all that good stuff. So please make sure that we are in it to win it. Any questions before we start today's lesson? Yeah.
This is our last test before semester finals.
This is the last test before the semester final, and what it will be is, it will either be the Thursday or Friday before finals week. I will very soon post links to review material for your final exam in Google Classroom, and from there I would say it's a very good idea to start reviewing now for your final exam, okay? And the way you review is just, you can work through the problems that are on that review, and then look at the answers, or you can straight up just sit back, relax, and watch 91 videos recorded individually for you of the answers of every single one of those questions on the review, okay?
Is that out right now?
Well, not right now, Braden.
Well, I was asking if it is.
Oh, I thought you meant to watch videos now. No, it is available now, but I will link it to Google Classroom here soon. All right. So with what we are doing today, so again, the attention to detail, I can't stress enough, is going to be very, very precise. Okay, so please, all the small specificities, the nuances, the small little details that you see, make it a big issue, because that's what this unit is all about. If you're needing to retest for Unit 4, the related rates test, that needs to be done by this Friday. Okay, I will let you on your own, just like other people have in the past, come to me and take care of that stuff, okay? Okay, alright, here we go. The Rolle's theorem. Rolle's theorem is a type of mean value theorem, okay? But instead of f prime of c equaling some number that's not equal to 0, Rolle's theorem, that 0, is actually just a form of mean value to where it's when the derivative does equal 0. Okay? And the derivative we get from this equation that we saw last time, which was f of b minus f of a over b minus a, aka y2 minus y1 over x2 minus x1. Now, for this 0 to equal, as far as a derivative, in a fraction form, all you need to do is make sure that the top is 0 and the something at the bottom is not 0, because it'd be undefined otherwise. And if the top is equal to 0, then your stipulation has been met. Okay? And for that being said, it's the third rule of Rolle's theorem. Rolle's theorem is a lot like intermediate value theorem. We have to specify all those conditions before we apply the rule. Okay? So that, real quick, was just a quick review overview. So rule 1. F of x is continuous on -2 to 3. Just so you know, this is an x value and so is this, like x1 and x2, aka otherwise known as a and b. Okay? So the second rule is what? You'd help me out. What's the second rule? Differentiable. So f of x is differentiable on -2 to 3, but this time not at the endpoints. And you know that you can't differentiate an endpoint. It needs local linearity. It needs wings like a bird. It needs both one-sided limits. Okay? All right. What's rule condition number 3? Yeah. F of a equals f of b. So I need to check, does f of -2 equal f of 3? And if it does, then all three conditions conditions are met. I'm not checking if f of negative 2 is 0. I'm not checking if f of 3 is 0. I'm checking, are they equal to one another? Because if they are, and I subtract them, I will get the 0 that way. So they could both be 20. They could both be negative 80. You see what I'm saying? So here we go. F of negative 2. A lot of this test, pretty much all of it, I'm going to say right now, is non-calculated. So you have to be on point with your fraction skills, with your plugging in, with your synthetic substitution, whatever it is, with speed, okay? So I know it's been a bit since we've done this, but we're going to plug into here just the negative 2. We're going to practice with synthetic division a little bit. Should you choose to use it, use it. Here we go. So we have 1, negative 1, negative 6. Okay? So I'm looking at plugging in negative 2 like synthetic substitution. Copy, multiply, add. Multiply, add. I got 0 for this. I didn't have to get 0, but I got 0. If I do the same thing, okay, this time I'm not going to use synthetic, or I'm going to use synthetic division one more time, and then I'll go to just plugging it in. If I chose to put 3 in, let's see what we get. Copy, multiply, add. Multiply, add. Because they're the same number, all conditions are met. Okay? Therefore, there must be at least one C value on what?
-2 to 3.
Good. I'm glad that you did not say A to B. On negative 2 to 3, where what? Come on guys, where what?
F prime of C
F
equals 0.
prime of C is equal to 0. Perfect. Alright, here we go. So now, I know this is just scratch work. I'm going to move it off. Let's find f prime of x. Yeah,
So how do you show that they're continuous and differential?
there's a good question. How do you show they're continuous? Well, think of quadratic.
Oh yeah, I know it's continuous.
So that's how you know. From your knowledge of parent functions.
So like how do you prove it?
You don't. You just state it from your knowledge of parent functions. You don't have to go all the way back. And remember the 3 rules of continuity? You don't have to do that. And differentiability too. Looking at this, you know that x squared and x, which are a quadratic and a linear function, they don't have cusps. Like they're not going to create a cusp. If it was absolute value pieces, then you would have to think about that. You see what I'm saying? Okay. Are we good? Alright. So here we go. F prime of x. Anyone, what's f prime of x? 2x minus 1. And looking at this, I want this to equal 0. Now I know this looks so arbitrary and unnecessary, but I want you to do it, okay? To fully use this proof, because you're looking for a C value, I want you to then rewrite this as variegated form of C. So that now all we have to do is input a 0 where we see f prime of C, and now solve for C. So show the conditions of Rolle's theorem are met. We did that here, here, and here. And find C that Rolle's theorem guarantees, which we did. And then the last thing that you'll ask yourself is 1/2 on that interval. Is it between negative 2 and 3? Yeah, so it works. Sometimes it may not work. Okay?
So in that case, what would C be?
You'll see. We're going to get there here in just a bit. Any questions from all of this, guys?
Do you have to show the synthetic substitution as proof for?
You did not. I only showed the synthetic substitution as a skill for you to build and refine and refresh for things that involve like fractions and stuff.
Okay. And then for your proof writing at the bottom, do you have to like add that C is 1/2 or just having the work there proof enough?
Having the work there is proof enough. Yep. We're good? Okay. So now that is a function equation form of doing that. Let's look at still applying Rolle's theorem, or sorry, mean value theorem this time, but we're going to do it with this graph and this function. Okay? guys. Small little details. Look for them, okay? Here we go. This function is right here. However, this means I'm only looking at 1 to 5. The interval from x is 1 all the way to x is 5, that's what I'm really looking at. So I'm really only looking at the gray shaded interval. Okay, here we go. So the graph of f of x is shown on the right. Visually, what is the mean value theorem trying to find? Yeah, go ahead.
Like the average slope.
The average slope. So the average slope between those two endpoints, what it's really locating is this. What is the average rate of change between this endpoint and that endpoint? That's exactly what it's looking for. Okay? And that average rate of change that we just graphed with this blue dashed line is representing this, which we learned back in Algebra 1. What's the average rate of change? You see what I'm saying? Which we now look at as this. Okay? What's my A? Anyone? 1, right? What's my B? 5. So, what is the mean value theorem trying to find? It's trying to find all C values on 1 to 5 where f prime at those C's would equal whatever the slope of that blue line is. AKA, it's trying to see when is the tangent line, or the slope of the tangent, equal to the slope of the what? Secant. And the secant slope is the average rate of change. The tangent is the instantaneous rate of change. We've been doing the average rate of change since Algebra 1. Cool. How many do y'all see? There's just one. And it's about here somewhere. If I drew a tangent, they are parallel lines that will never touch because they have the same equal slope. And what it's asking me to do is what is that C between 1 and 5 that would create that tangent. So it's that x value right there. You with me? Okay, so let's go. Show the mean value theorem applies and find the C that guarantees. Okay, number 1. Here we go. This is f of x. Is it continuous? No, it's not. Oh, there we go. On the interval, it's continuous. But all by itself, it's not continuous because I have a piece where you could divide by x. So there's a possibility somewhere, because it comes from the parent function 1 over x, which we know what 1 over x looks like. There's a piece somewhere where it would be undefined at that vertical asymptote. So here, this is not continuous, but it is continuous if I'm just looking at that smidget, that small little interval that they wanted us to look at. Okay, so that's why we have to put, guys, f of x is continuous on a specific interval. Okay? Step 2, what are we saying? F of x is differentiable on what? So differentiable on, perfect, 1 to 5, but without the endpoints. Condition 3, and I know we can look at it by the graph and tell, right? But I want you to give me the numbers. F of 1, is it equal to f of 5? Well, what's f of 1 equal to? Yep, like put it here if you have to. Put it in the equation, right? So 3 minus 5 is negative 2. What would f of 5 be equal to? 2. Are those equal? No. So we know that Rolle's theorem would not work. But mean value, it does. Now I just did that just so you can compare and contrast mean value and Rolle's theorem. You don't need this for Rolle's theorem. Or sorry, for mean value theorem. You don't need that condition. Okay? So the theorem is still holding. And because these first two are good, you're going to say, therefore, there must exist a C value, or let me change that, at least one C value. What's the next word that I write?
On.
Yep, on what?
1, 5.
1, 5 with?
Parentheses.
Parentheses. Perfect. On 1 to 5, where f prime of C would equal what?
F of B minus F of A.
F of B minus F of A. So f of B is like saying what's f of 5 minus f of A over B minus A. What's f of 5, guys? What did we say f of 5 was?
2. No, 2.
2. What's f of 1? Negative 2. And then this is 4. So what's my slope?
1.
1. That's what we want it to be there. Here we go. We're going to differentiate this equation right here. And just a quick rewrite would put it like that. So what's the derivative?
5 over x squared.
5 over x squared. Perfect. So we want to see when is 5 over, so here's what I want you to do. I want you to put f prime at C is equal to 5 over C squared. You with me? And we're going to replace f prime of C with 1. So that when I solve for C, what are all the answers for C? Plus or minus what?
Root 5.
Root 5. Well, what's my answer?
Just plus 5.
Just plus 5, because that's what lies in the interval. So we could say the negative version is extraneous, or just put only the positive root 5. Questions? Okay, so there's some good practice with that. Equation and a graph form. I'm going to show you the application just real quick on this same video, then I'll stop the video and start the next one, okay? Here we go. What does all this mean? It means this. If I'm looking at, so they used to have speed traps back in my day. So they didn't have necessarily, speed traps for you now is just a cop sitting on the side of the road with a radar gun. Right? And it's just taking derivatives, and as he's pointing it at you going, when he pulls the trigger on that radar gun, it's measuring your velocity that instant. You see what I'm saying? And if he holds it down, the velocity could change. Like it could be 80 miles an hour in a 55 mile per hour zone. And as you see him, oh, he can see that you're slowing down, if you did not know this already, as he continues to hold the trigger on that radar gun. Okay? Back in my day, they used to use road traps, as far as speed traps, that look like this. So like way over here, so we could say like the road is just here, right? Just a major highway. And the major highway, they had like overpasses, right? Sort of something close, right? We're not going to go crazy with it. But this was an overpass. And on this overpass, a cop car could be right here, just parked. And as you drive underneath this, and you're heading that way, there is another, I don't know if it lets me, there's another cop way down the road, right? At another overpass. So for this particular problem, we have a distance in between these two. The distance is what? 5 miles. You with me? And on this, here's you. So here's the highway, if you will. And here's you. So you're in this car. Please let me do it, please let me do it, please let me do it. Okay, cool. So you're here, and as you pass him, you're just going to go down the highway. 5 miles later, you will reach this guy. Now let's read the problem. It says you are driving at a car traveling on an interstate highway at 50 miles an hour. Okay? And you pass a police car. So right here, your velocity, right here, was 50 miles an hour. 4 minutes later, t is equal to 4 minutes. You pass a second police car traveling again at 50 miles an hour. The speed on the interstate is 60 miles per hour. The patrolman in the second car gives you a speeding ticket for going 75 miles an hour. How can you prove that you were speeding? What could I do?
You can't go 5 miles in 4 minutes. You go 50 miles per hour.
Okay, so you already know, you can already see the math in your head. Because you know 5 miles is close to 4 minutes, and the whole 60 miles an hour is a mile a minute. Okay? Let's do the math a little bit more though. Here we go. Remember this equation back when things were much, much easier? So distance is equal to rate times time. What's your rate? Well, that's what we're looking for. I know my distance is 5 miles. My time is 4 minutes. Obviously, for me to get my rate, I need to get my conversion factors in the same language, right? So let's change 4 minutes to hours. So here we go. Dimensional analysis, we have what? 1 hour is the same as 60 minutes. The minutes will cancel to a form of 1, and I have what? 2/30ths or 1/15th of an hour is what this should be. Because now it's in miles per hour. So 5 is equal to r times 1/15. What do I do to get r by itself? Multiply by 15. The r was 75 miles an hour. Can someone tell me, what does that represent right there that we just calculated? That average rate of change. That would be as if I was right here, right? And I went 75 miles an hour, and at that instant, right when I passed underneath that car, the cop car, I put the cruise control on. And I just left it at 75 miles an hour the entire time. It would take me 4 minutes to get here with the cruise control on. With me? But when I saw that cop car, I slowed down big time to that. And when I saw this second cop car right here, I slowed big time to this. Do you understand? So how fast was I ever going even faster than 75 miles an hour? Yes. I was going even faster than 75, because if this is the average, that means some of the time that I was driving, I was above 75, and some of the time that I was driving, I was below 75. but it averaged out to 75 miles an hour. Do you understand? That's what mean value theorem is. It's trying to find those particular moments in between A and B where that derivative is equal to that average rate of change. Okay? Alright. So that's the conceptual understanding of it.